Hey.
Hello.
Hi, everyone. I think Fabian said he was running late or might run late. Shall we start? So I have both of them. So I'm just wondering how we start on this decomposition for one table. I was wondering if we just create a new DB and live with the fact that for people who have some environment variable turned on, it will use the new DB. If not, then it will use the old DB. Does that sound like a approach that we can take? What's any other ideas?
Yeah, I was just typing. This is maybe slightly tangential to what you're saying, or maybe related to what you're saying, which is if we add dynamic analysis that prevents cross CI to main queries, then we just start solving those failing tests as the first step. So like we have we have a set of failures and we just keep merging merge request after merge request until we have no more joins that violate this rule that you can't join between CI and the main database.
Yep.
And then the first like series of merge requests are just basically just changing a lot of queries to not use joins anymore.
Yeah, I think that's the second challenge. I think the first challenge is creating the tables. And my question is that, do we create a copy of the tables, copy of the schema, which I think we have to do, or we move the tables across, which I don't think we can do.
I'm kind of thinking that this is like two-step process. And I have this proposal about the create schema, because I would like to, I think we have to keep the table like forever on the main database, probably for another 2 years. Anyway, because not of people will like migrate. So we need to retain the current like data and still use that for as long as it is needed. So now the question is like how we can make a distinction between something that should be decomposed and something that should be main. So I had this proposal about create schema, that like we create schema CI. You alter main database and move the CI instance variables into this schema to indicate that this is exactly the table that got migrated. And now we just basically, next step, we create a new like CI structure SQL with these like CI instance variables only. And the tricky part right now is like we need to, and also with this create schema CI, but the tricky part right now, we need to our probably db/ci migrate execute in both contexts, main database and the compose database, or
Yeah.
pretty much always. And now, like in the GTK, like whether we use many databases or not, I think it's like a matter of the database YML. But whether application uses many database or not to store data, it's more a matter of like probably what you wrote, environment variable, or maybe a feature flag, or anything else that may be useful for us. So I know that Yanis, I think you didn't like my schema approach, but I'm kind of trying to figure out how we can like mark what is decomposed and what is not decomposed out of the main database to better manage later what should be dropped out of the main database, and also like retain, because like the part about schema is like the schema actually allows us to make, if you don't prefix your table name with the CI dot, if this schema is not in the search path for the given database connection, it will be not automatically be considered as a CI builds to be used because it's not in the public schema. So technically, for the development environment, it's pretty great because we can actually keep the compose database in the main database, but ensure that in the development and testing, there are no cross joins that are performed on the SQL levels because of the search path. Because our CI is not in the search path, so like your CI bits will not be unwinded into the table out of the CI schema because the CI is not added to the search path. Only public schema is added to the search path by default. So it has this added benefit that we actually like make SQL to not really see CI builds unless you configure the connection to see the CI schema. So like even without things like disable joins, you're just gonna see a test failures when you try to cross joins within the same database, which we know it's not will not be worked like across different databases.
Yeah, that's handy.
So
And
like,
I think, yeah,
please.
I think we can set multiple migration paths. So even if we have like CI migration something, then we can set it to run in the main DB and the CI DB. So that sounds like relatively give it that. You were saying?
Yes, like database YML actually give us migration paths. So exactly what you're saying. I think we can set DB migrate for the main database and DB CI migrate for the main database, DB post migrate, or whatever else we need. And it should just work simply. So like then the question is like how we handle things like background migrations that may execute depending on the context. But like I guess this is the next step to figure out, because like at some point migration executed will be executed in the context of very specific database, and like these migration will not be able to cross join databases. So like whatever you schedule for the asynchronous processing, we need to provide the context for the background migration, for example, or like any other async job that is scheduled, in what context database it was executed. I mean, like from the active record model, it's effectively, I think it's named role or scope. I don't know. They actually name it somehow in this context.
Yeah, that sounds like a valid approach. The only thing that worries me about schemas is if we ever release them to self-hosted, to self-managed instances, is that anyone can mess with their path and include that schema in their path. And we have seen crazy stuff happening in self-managed reported to us. But we can be explicit about that. So we have we are even at the moment discussing being explicit on which schemas are in the path. So we can work with that. We can have a very explicit directive that we say those are the paths and that's it. And we can even have it. So yeah, this works.
So I have the question: do you configure a path on per connection basis, or is it like global configuration for?
You can do both, and at the moment we depend on. And this has caused a lot of problems. Not a lot, but it has caused problems with some self-managed instances. We depend that the user defined on the Postgres side has only the user and the public path in its path. But if someone, the administrator of the Postgres, goes and changes the path for the user, so for example, now we are using the GitLab user for connecting to the database. If they change it, the behavior of GitLab changes. So this is a problem either way. So I think that going the other way around and setting the path explicitly, it's even better either way.
I would aim on like actually setting a path on the connection as soon as you open connection, because like there are like two benefits. In this model we want different path to be configured for the production, like more permissive. So like including in the search all possible schemas that we want to traverse, but like in the development we want to like be decomposed to forbid cross joining. So, but like the question is like, is there a usage pattern, Yanis, that you see that user would like to, administrator would like to configure different path, search path than the public?
Yeah, we have seen people doing weird stuff like moving GitLab from public to a different name, for example, because I don't know, they had GitLab in public and then they backed it up in GitLab_backup, and then for whatever reason they wanted to switch to GitLab_backup, and they switched the path to using that. And a problem with schemas is that you don't know about it. So I have seen a customer, a self-managed instance, where at some point they switch the path and half GitLab tables are in public, half GitLab tables are in another schema. And so at some point, we added some migration helpers that were explicit about public, and migrations were breaking for them. And after going with through the problems with them, we realized that they had the tables, they had a split, not brain, but a split schema. Half the tables in one schema, half the tables in another schema. And it started because they moved something. I assume they moved, they started using a secondary schema to test something, and then they forgot to change the path back.
Okay, so that's like something that we need to investigate. Like if we add additional schema and start leveraging that, will our customers go like around that?
The problem with paths is the same as with all paths in general. If for whatever reason a CI table exists in both paths, you don't know. It's not very visible to you to us as an application which table was used if we're not explicit. So if we just say select star from CI underscore I don't know CI instance variables, whether a Postgres will pick the CI variables that is earlier in the path, and that's it, because it goes through the, as with all paths. But we don't know what happens there, and this is prone to errors. So I think that we have to fix that either way. So this is something that can happen with schemas in general.
Yeah, so I'm kind of thinking like, Right now, probably we need to figure out, but like we're not gonna figure out that easily because like we are not fetching like schemas available and how many of them, and we are not publishing that into our like usage pings.
So there is another layer of problems there, and there are some self-managed instances that they don't want to give us access to their full database. And this is something that now that we're moving with Sharding, I think that we have to be more explicit that we own the database and we can add databases, add schemas. So we have seen self-managed instances even saying, please tell us about all the schema updates so that we can run them manually before you do them, because we don't allow GitLab to make the schema updates, create schemas.
So how? So then my question is, how are our current customers create schema GitLab partition dynamic?
Yeah, that's where it hit them. And the problem there is that we are not very explicit on the fact that no, we own the database. We have to own the database. We want to be able to add to add extensions, to add schemas, and with Sharding we want to also add databases. So we cannot anymore we will have to find the solution there.
Can we?
That. This is
can,
very
can we just ship migration name, create schema CI, and see how many customers we start complaining?
Yeah, that's the administrator of old that I like, where you just break and wait for them to come back to you. But yeah, I'm not sure if we can do that.
No, I'm serious, because we are depending more and more on schemas. Like even today, we already have create schema.
Yeah.
We already like on public, and we already create two additional schemas.
Exactly.
So
exactly.
we already embrace schemas. So can we now create schema CI?
Yeah, we can do that. We can create a migration. Most probably the same people that came back. So we realized about all those problems when we created the dynamic and we started dynamically adding partitions, etc. So that's the point where we have seen all those problems. There are hundreds of thousands of GitLab instances. It's not like we have thousands of instances that have this problem, but we are in a lucky position that we have so many instances out there that some of those do some things out of the ordinary. I don't think that we can solve the problem for everyone. I'm just saying that we have to be a little bit more explicit and just a small warning that we will get complaints if we go, just start adding things.
I mean, because we may basically start requiring, hey, if you don't want to give us schema, you just need to create the schema ahead of the time and give us a opportunity to move tables between schemas within the single database. And maybe if people don't want to give us that, this is like a requirement, really.
I personally think that if we do sharding, especially if we start at some point, we will do rebalancing, we will do dynamic, not today, not in a year, but sooner or later, we need to have access and do whatever we want for rebalancing, for whatever. So I think that we will have to be more explicit on the fact that we have full ownership of the full database server. Because at some point, we will also need to create databases.
I know, and this is tricky, and I assume that we're gonna have a lot of customers running Clyde SQL with a single database configured, and they will very likely be very hesitant to migrate into many databases, and we still need to support this model for time being, and probably in 2 years from now say we are no longer supporting that, you need to forcefully migrate out of that.
Yeah, and this is something we have to check, and maybe we will have to support multi-schema for those cases. This is not a solution that I personally like. I'm in favor of the multiple databases, but yeah.
Cool. I would still try like with the separate schema.
Yeah.
To be
So
honest.
what I was
It's like from the management point of view, like of your perspective of the database, it makes things better organized for us to also like see, migrate, and like ensure the consistency.
Yeah, I agree. So back to what we were discussing in the beginning, I think that having the migrations target specific schemas or specific databases is the easy part. One thing that we will have to do is to also switch the way we set up the structure.sql, because for new self-managed instances, or local. We use one file, it's structure.sql, it knows everything, it goes there, it uses the path. We are not explicit about the schema anymore, and this is a change we made at some point. And it uses whatever the default schema is on the path, and installs and set up GitLab, the GitLab database. So if we want, and we will want to use multiple schemas and then multiple databases, we have to be also explicit on those, on what we're going to do with structure.sql and setting up a new database.
So basically, you are saying that right now you are missing a way to enforce that we use like a public in the structure or something different.
Yeah, we have changed it on purpose. So we were explicit on using public, and at some point during 13, I don't remember, at some minor version of 13, we went back to not being explicit, which gave us some benefits, but now this is a problem for what we're discussing. So we have to go back to being not only being explicit about schema, being explicit per table or per table, per object about schema.
Is it actually right now risky stuff to do?
No, it needs work. And going to multiple schemas is easy, as you said, because you just add the schema in front of the table name of the object name. Going to multiple databases will mean that we most probably will have to have multiple structure.sql.
Yes, like multiple structure SQL, and actually this works pretty well.
Yeah.
I noticed one more aspect. Sorry that I'm hijacking this call so heavily. I noticed one extra aspect, like I know that structure SQL is not very good, like for the like human eyes, but all the partitions are like replicated so many times, like in the structure SQL, where they could be actually be written in much more efficient form that reuse the main structure.
Of course, that's true.
For example, like we have product analytics experiments, 124 partitions, which actually is like 95% of the structure SQL.
Yeah, that annoys me so much, and it's easy. We can move all the partitions outside, and this is only for the static partitions, because the dynamic partitions we create them dynamically using a worker. But for the static partitions, at the moment we have everything in structure.sql. At some point, sooner or later, we should move it out and have a file that it's not for to be human readable, and use that. But because the structured SQL is also very useful as the single source of truth of what we have in the database. So a lot of people visit it, including me. We could have multiple files. This is not a problem.
Yes, I'm kind of thinking about like this optimization that like we are right now, our schema is like highly unwinded, but at least partitions like don't need to be unwinded. They could, like there is like a structure in the SQL that creates you a partition on top of the current table.
Yeah, but it has the good thing that it is a valid SQL file, so you can take it and run it, and you're done. Which is very important. It's useful. It makes things very simple if you think about it. So there is a benefit and there are drawbacks, but there is also a benefit. So anyone can take it and set up a GitLab just by copy pasting or using it. a structural load.
I don't feel like we've answered this original question. And I'm really, yeah, like talking about the schema move and stuff like that. I can see how it solves some specific problems, but I don't feel confident we figured out how to actually tackle this next part of creating a new database.
I think the main question is whether we need to leave the old table, and the answer is yes. So whether how we want to create a new database, it's really up to the person who's going to hack it together.
So I'm kind of like thinking that exactly how it's gonna look like. We just create CI structure SQL manually initially with the table that we want to move. And we're just gonna create migration. Like when we add the migration, if you're gonna want to access CI instance variables, you're gonna have to add the migration in the CI migrate folder that will be executed both on the main and on the CI database concurrently. And our CI job that checks the DB structure SQL, right now it's allowed to failure because of the presumably false positive. We should aim for making this failure, because this is the job that actually also checks the consistency of the generated structure SQL if they reflect exactly migrations executed. So then the tricky part is like, can we discover a case where someone puts CI instance variables into main database but doesn't put it into CI migrate? Because then we would end up with the schema being different between main and the CI, because migration was put in the wrong place.
Sorry, you're saying put data or change structure?
Sorry, can you say the question again?
Are you saying put what? Are you saying
so
put a migration to change structure? Is it?
Yes, but because as soon as we migrate CI instance variables, we don't move the current structure. It's effectively a snapshot. Now, for this table, we need to add new migrations into CI migrate for this to be executed on both databases. We're not gonna create, or maybe we're just gonna create the CI migration in two places, but it seems pretty not really great. So now we need to discover a case that someone puts migration into DB migrate, but not CI migrate, to change the instance variables. And it's gonna only change that on the main database, but not on the CI database.
Can I ask a question? Can I take a step back? Why do we need, can we recap, why do we need to keep both tables? Because it is easier, but it can cause a lot of problems. So why do we think that we should keep both tables?
Just the answer is simple. We need to ship migration earlier than we actually migrate data on the product.
Oh, yeah. But at some point, we will have to drop it.
I'm not even sure if we're gonna drop it. We maybe just gonna leaving in this separate schema. Because for dropping to happen, you need to ensure that every customer did upgrade into a decomposed database. So that's the tricky part, if we can drop it and when.
Yeah, we will have to be explicit at some point. Otherwise, it will be a mess and it will be error prone.
Yes.
So to answer Camille's original question, I think we can detect someone has changed the CI table. We can do comparison. CI has access to both databases. I think that's fine. Just a lot more work, but yeah, there has to be a point we drop the tables, but it could be 2 years from now, it could be 3 years from now, don't know. But there is a time period where we have to have this overlap. we can't avoid it. Yeah, I agree.
Can we now, like, because like another aspect, like if you would have a schema and we assume that, let's say, a single structure SQL manages a single schema like public and CI, can we like, I don't know, like, is there some other way that like we could, let's say, accommodate CI structure SQL into main database and like perform these migrations? I'm not sure like if this is, I'm thinking like it doesn't make sense. Because I mean schema like defines like a logical partitioning of the database, right? So maybe structure SQL doesn't describe like the database configuration, database schema, so the database structure as a whole, but rather describes a schema only. But I don't think that's probably
No.
good idea.
Yeah. I don't know what kind of assumptions Rails makes about that. I think Rails doesn't know about schemas much, so.
Because like
Sorry,
asking,
I was asking because I was under the impression by following the discussion and the comments by Dylan and Adam that we had a solution that pretty much works, and we can at some point we have an idea of how to be able to at some point to drop the table. Am I right?
Yeah, I don't think we have to drop the table. I think there's competing concerns here. One is about the application code being coherent, which is, say, this structure.sql will have to have the CI tables for as long as we allow any customers to have CI tables remain where they are, or so long as we allow a grace period before customers have to migrate their data, we'll have to keep it in structure.sql. So the application will have to be for a very long time in this state where it knows about two different tables. But from the actual database instances we run, we will migrate the data from one place to another, and then we'll truncate the data on all the other tables. I don't know if we can actually delete the tables in our production instance without our production instance being in a kind of weird state where it doesn't match the structure.sql file, and that may not be a good idea. So we'd probably truncate the tables, or if there's something more efficient we could do, we could maybe delete the tables and then recreate them if that was more efficient. I don't know.
yeah, so like we cannot drop tables until all our customers migrate. That's really like the clue. We can drop data on the production fairly easily as soon as we validate that we switch over. And this can be like, as Dylan saying, truncating, recreating structure. Probably truncating is like more reasonable to do. But that's really the thing.
I have a feeling truncate might be really expensive from Postgres's.
Probably because of the foreign keys, right?
Foreign keys maybe. Well, we would have removed any foreign keys into the tables that we truncate by that point in time. But I just thought the truncate meant you had to clean up the dead tuples, and like that'll all go on the wall stream, and it'll all be these things that Postgres has to clean up, as opposed to deleting a table where Postgres does it to just unlink something. I might be not correct about all of that, but
Yeah, we will have to check that. I think that truncate is way faster than delete, because I think that truncate just truncates everything and without going through all the hooks. But this is an implementation detail. But yeah, if we're going to drop everything, maybe just drop the table and recreate it.
I feel like I understand the plan better now. I was a little bit confused, but I get now that the application code is going to start creating these new CI tables, and GitLab, the Rails application, will just know about the two different tables, but we will just only ever choose which one to connect to based on a state of a migration.
It's actually like it's gonna connect to like the correct database based on like, I don't know, environment variable, feature flag, or whatever else you pick. as a criteria, because like in the model you can define many databases.
So we have to have all migrations, as we said in the beginning, and I'm repeating for myself because now I am also understanding this better. We have to make all migrations dynamically choose which schema or database they pick. So we release the migration once. Let's say that we want to add a new column to that table. So we have to have the tooling to have the migration that will say add column to that table.
Not really.
Or do you think that we will have two migrations there?
No, like you don't really need to do it like that. As soon as Rails processes migrations, it's gonna, in the given context, like the connection, execute, add column, it's gonna define the because like you define a connection, and under connection you define a database like connection string, and under that you define a migration that you want to run, and now you iterate on each of these connections, each of these database migrations. So in the migration context, you already have the database configured properly for the migration from the given path being executed. So what's gonna happen in the Rails out of the box is like, if you have the, let's say, add CI column RB, it's gonna be executed twice with the migration context pointing once to the main database, second one to the another database. And now, as long as you use active record migration connection, it will work just out of the box. Now, if you use active record base connection, it will, well, it fails. So we may, to some extent, fix migration helpers to ensure that it uses the correct connection from the migration context, not the legacy connection handler, something that we've been discussing with Tong on his work. So I would assume that right now in the 70% or like 80% of the cases, it will just work out of the box. There are like more cases where we need to fix them, which is like the migration helpers that we need to make migration helpers aware of the connection being used. Second, we need to make background migration be aware of the connection to use, because background migration then is being executed in the slightly context. And right now it assumes only a single connection.
In general, data migrations, we'll have to fix data migrations to pick the correct table. And one minor thing there is that we don't use the models, the application models in data migrations, because we don't want, if code changes, we want the migrations to be able to run still. So at the moment, we replicate and we create a local model. So we will have to have a solution to easily create a local model for example, CI variables that will also have the correct connection details in the data migration. But I think that, and Adam can correct me on that, I think that this is something we can do.
Yes, I think we need to figure out what is like the best way to do it. I don't know yet that, because the same problem applies to the background migration.
Yeah, it's the same one.
All right, sounds good. I might have time to try hack something together, but if someone gets to it, I don't mind. Let's discuss the due date tomorrow when Craig is around. There's probably a Craig question as well. Yeah. Thanks, everyone.
Have a good evening.
Bye-bye.
Have a good morning.
Good day. Yeah.